All right, guys, today we are going to talk about graphing and solving. Okay, graphing and solving one-step equations. Okay, so for the first thing, we're going to talk about how we actually graph these, which is on a number line. Okay, so what we talked about last week was that for the solution to an inequality, you're going to have a set of numbers. So for example, I'm sorry for this little, I don't know what that is. So if x is equal to 3, that means that the solution is 3. It can't be anything else. It has to be 3. But what we talked about last week is if we have an inequality, that means there's an infinitely many, in most cases, amount of solutions. So if x is, and remember this is greater than or equal to, make sure you are reviewing these. If x is greater than or equal to 3, that means it can be 3, but it also can be anything greater than 3. It could be 4, it could be 5, it could be 100, it could be 1,000,000. Okay, so any value that is larger, it could also be 4.5. Okay, it can be any single rational number bigger than 3, or equal to 3 as well. Okay. This means less than or equal to 3, so it could be 3 or less than. It could be -2, it could be -4, it could be -100.5. It could be anything less than or equal to 3. Okay, so if you notice these top two, these have closed circles. That means that that point that you plot it on is included. Okay, now down here, we have x is greater than 3. So there's no equal sign under it, which means that it could be like 3.011111, but it cannot be exactly 3. So you would put an open dot over the number 3, and then you would point it in the greater than direction. Lastly, x is less than 3, so it's going to be an open. So 3 is not included, so it's excluded. And then it's going to point to the negative side. So it could be 0, it could be -2.5, it could be anything less than 3, but it cannot be exactly 3. Okay, and so these are both open dots. So pay attention to that. We're going to graph some of these first, and then we'll do very easy, we'll solve some one step. Okay, so the first thing we have to do is I like to write, so x is greater than 4. Okay, so that's how we would translate it. Okay, so if it's going to be greater than, so notice that these are all blank. I did that on purpose because depending on what your solution is, that's the numbers that you need. Okay, so if it's going to be greater than, I'm going to start with the number 4 and then go 5, 6, 7, 8, 9, 10. Now, if you wanted to do 0, 1, 2, 3, 4, 5, 6, you could do that as well. But I do this just so I can better represent this. Now, these I graphed right on the line. One thing I do like to do, I think it makes it a little neater, is I go a little bit above the line. It's going to be an open, okay? So this is open because there's no greater than. And then it's going to go to the right, okay? So open and to the right. Now this means x is greater than 4. So it can be anything bigger than 4, but it can't be 4, okay? Let's try another one. So x is less than -5. Okay, so if it's a less than, my arrow is going to go this way. So what I actually do is I'll start with -5 over here, and then I'll go backwards. Okay, so -6, -7, -8, -9, -10, -11. Okay, again, if you wanted to start with 0 here and then go to -5, this is just so I can see everything. So I'm going to go a little bit above -5, and then it's going to go to the left. So less than goes to the left, greater than goes to the right. Okay, one thing I do want to point out is notice that my x values, or my x variable, is on the left side. If you keep your variable on the left side, the direction, see like how this points that way, it actually represents your like arrowhead. So when you're solving these, keep that in mind that you want to try and keep your variable on the left side, because then it kind of helps you if you do mix up greater than or less than. The greater than points to the right, like the arrow, and then the less than points to the left, like the arrow. So that's another thing you can keep in mind. Okay, so this one, x is greater than or equal to -3. Okay, so since it's going to go that way, I'm going to start with -3, and then remember, if you go this way, you're counting up. Okay, so now this one is going to be above -3, but now it's going to be filled in because it's included. Okay, because it's greater than or equal to, and then draw your arrow to the right. Now I put number 4 in here because notice that my 10 is on the left-hand side. So the first thing I want to do is I want to rewrite this as, so if 10 is greater than or equal to x, that means that x is less than or equal to 10. So remember, with equations, if x is equal to 3, then we could just say 3 is equal to x and be done. We don't have to flip it around. But if I want to follow my rules where my arrowhead points the direction that I want, then it's really important that you rewrite it like this before you graph it. Okay? If you're solving and you leave it like that, that's fine. But I do find that when people don't rewrite it, they end up graphing it in the incorrect direction. Okay? All right, so x is less than or equal to 10. So that's going to be filled in and then go to the left. Okay, so that's how we graph inequalities. So the next thing we're going to do is we're going to do, and I'm actually going to do just 4 examples. I'm going to save the bottom part of this for the next lesson. Okay, so we're just going to do an example of each different operation, and then I'll let you guys do a little practice. Okay, so x plus 3 is greater than 7. Okay, so basically I need to figure out what values can I put into here that will make this true. Okay, so we're going to actually solve these exactly like you would solve an equation. So the opposite of adding is subtracting, so I'm going to subtract 3. So x is greater than 4. So this is my solution. X is greater than 4. Okay, and then I'm going to graph that like we did on the previous page. So 4, 5, 6, 7, 8, 9, 10. This is going to be open, and it goes greater than. Okay, let's try another one. Now I have g minus 4, so I'm going to add 4 to both sides. So g is less than -9 plus 4. The negative has a larger absolute value. 9 to minus 4 is 5, so it's going to be -5. So g is greater than -5. Less than. Okay. So again, if it's less than, it's going to point into the left. So I'm going to do it this way. And the nice thing about this, guys, if you did pick different numbers, as long as -5 is on your number line, that's fine. I just like to have my arrow actually like on my thing. Okay, the next one, 4b, that would be multiplication. So the opposite is division. So we're going to divide both sides by 4. So b is less than or equal to -5. Okay, a negative divided by a positive is a negative. So b is less than or equal to -5. Okay, so I'll actually use the same number line as above. And notice I'm going at even increments. Okay, make sure anytime. So this is going to be included because it does have an equal sign, and then it's less than. And the last one, we have D divided by 6. So the opposite of that is multiplication. So I'm going to multiply both sides by 6. Now, when we did equations, I did say you could put a 1 under the 2 and then cross multiply. Please do not cross multiply with inequalities. Okay, do not. So this will cancel, and then 2 times 6 is 12. So D is greater than or equal to 12. So 12. 13. Okay, so that is how you graph and solve one-step inequalities. On the next lesson, we'll go over, we do have one special rule when we're dealing with multiplying and dividing negatives. And then tomorrow's lesson, we will do two-step inequalities and graphing. Okay, so please complete the Google form. That is a exit ticket to make sure that you can graph and solve one-step inequalities. Thanks, guys.